I hope we are live. चलिए ज्वाइन कीजिए, चलिए आ जाइए। चलिए 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 सब लोग आ जाइए। जिन्होंने लाइव सेशन अटेंड किया या जिन्होंने ज्वाइन किया तो कमेंट सेक्शन में लिख लीजिए। Please write hi, hello, you, whatever. Okay, Hafsa, hi. Fahim, hi. Hi, Fahim. Zarka, hello. Sharik, salam alaikum. Walaikum assalam. Arvina, hi. Hafid. Hi. Asif, hi. Hi, फरजाना। चलिए तो स्टार्ट करें। चलिए स्टार्ट करते हैं। आई होप बोर्ड इज विजिबल टू यू। I hope it's visible to you. I hope it's visible to you. Please write. Yes. I hope board is visible to you. Okay. Okay, let's start. Let's start. Okay, let's start. Today's session is totally about atomic structure. Today's session is totally about atomic structure. Wait a second. Okay, nice. I'm audible to you? Am I audible to you? Yes. Let's start. Today's session is totally about atomic structure. We discuss about what is dual nature of metal and radiations. We also discuss about what is atoms and what is nuclei. We also discuss about what is radioactivity. Today we will discuss about, that's very important for you as far as your NEET examination and IIT-JEE examination is concerned. That is, we will discuss here what is Schrodinger's wave equation. Schrodinger's wave equation. Today's session is totally about quantum mechanical model of atom. That was independently given by Schrodinger and also it was given by Heisenberg. But Heisenberg's session we discussed some questions of Heisenberg's uncertainty principle. Here we will discuss Schrodinger's wave equation, the questions regarding Schrodinger's wave equation. Here we discuss very important, you know what is Schrodinger's wave equation? That is dou 2 psi upon dou x square plus dou 2 psi upon dou y square plus dou 2 psi upon dou z square plus 8 pi square m into E minus U psi upon h square equal to 0. This equation, this is the equation that was given by Schrondiger, and you know that this Schrodinger's wave equation, this dou is nothing but it is a partial derivative, it is second partial derivative. So how do you mean by dou? You know what is dou psi upon dou x? You will tell, sir, what is differentiation of psi with respect to x? But it is dou. Dou means here it's partial derivative. Here psi, we know that psi depends upon x, y and z. You know that psi depends upon x, y and z. Why, sir, it depends upon x, y, z? Because psi is nothing but it is orbital wave function. You know that orbital is nothing but it is an electron cloud around the nucleus. Orbital is nothing but it is a three-dimensional region in which the probability of finding an electron, that is maximum. That three-dimensional region is called the orbital. And you know that electron, it has, according to de Broglie, like radiation, electron has also dual nature. It has also dual nature. It means it has particle nature as well as it has wave nature. It has particle nature as well as it has wave nature. It means if it has particle nature, it is due to the mass, because electron shows some of the phenomena that depends upon particle nature, and electron also shows some of the phenomena that depends upon the wave nature. You know that. The thing is that if it is dual, electron also acts as wave. Since wave is localized or delocalized, sir, wave is delocalized. Wave is delocalized. What do you mean by delocalized? We know delocalized is that thing which cannot be localized at a particular point, but we can localize that in a particular region. We cannot tell where is electron. As far as Bohr's model is concerned, we know that electron revolves around the nucleus in a particular orbit. It means you know that where is electron. You know that it is either in first shell, second shell, third shell, up to so on. But the thing is, electron, the radius of an electron, the velocity of an electron, the energy of an electron, you can determine according to Bohr the energy of an electron, also the velocity and the radius. Where it is an electron, is it in first shell, second shell, third shell for hydrogen and hydrogen-like species? But the thing is, you cannot determine simultaneously the position, the velocity, or the position and the momentum of electron, or you cannot simultaneously calculate the energy with respect to time of an electron according to Heisenberg's uncertainty principle. You know that? Yes, Musab. Yes, Musab. Would you like to say something? You raise your hand. You raised your hand. Okay, we'll see. You know that we cannot determine simultaneously the position as well as the velocity of an electron as far as using the Heisenberg's uncertainty principle. We know that according to Heisenberg's uncertainty principle, we know that we cannot calculate simultaneously the position and the momentum of an electron. You know that del x into del p is greater or equal to h upon 4 pi. According to Heisenberg's uncertainty principle. But the thing is here, also you can write this as del x into del v, it is greater or equal to h by 4 pi m. Del x into, you can write also in terms of energy, del E into del T. Del E into del T is greater or equal to h by 4 pi. Oh, sir, what is del x? You know that. You have discussed that. What is del x in class 11 or in earlier class or in class 12th also. You know that what is del x? In uncertainty in position. What is del p? It's uncertainty in momentum. What is del v? Uncertainty in velocity. What is del E? Uncertainty in energy. What is del T? Uncertainty in time. Minimum uncertainty, product of uncertainty, the product of the uncertainty of position and momentum, the minimum uncertainty, it will be h upon 4 pi. Minimum uncertainty. And if the uncertainty in position increases, which implies uncertainty in another, that is the moment, it will decrease. It will decrease. Yes. Okay, Musa. Now the thing is, if the uncertainty in position increases, for example, you have fan, you know that you have a fan in your home. I will tell you what will be if a fan is moving, the speeds of a fan, they are moving at higher rate, at faster rate. I will tell you what is the position of that speed. You will tell, sir, the speed, I don't know, sir, where is this speed, but I will tell you the speed is in a particular region, in this region where these three speeds is located, whether 3 speeds, 4 speeds, whatever. The thing is that you are certain about its velocity because it is moving at higher rate. What is that rate? You know that, but you cannot locate its position. You cannot locate its position. And also, if I tell you locate its position, what do you have to do? You have to stop the fan. You have to stop the fan. It means you don't know the exact velocity of fan. You have to stop that such that its velocity becomes 0. You suppose that for calculation of position, the thing is that if you want to calculate the position, there is uncertainty in the momentum. If you want to calculate the uncertainty in momentum, there will be also the uncertainty in position also. But if the uncertainty in position goes on increasing, then the uncertainty in momentum or velocity, it will go on decreasing. Same is the case for energy and time. Is that clear to you? I hope. We don't have to discuss this Schrodinger's wave equation here. We have to discuss some of the questions that were asked in January session or April session or in NEET examination. PYQs, previous year's question, we will discuss here. The thing is, I will give you some, I thought there some of these misconceptions of Schrodinger's wave equation and Heisenberg's uncertainty principle are in students. That's why I discussed some of the important points regarding quantum mechanical model of atom. Why this quantum mechanical model of atom comes? Why? Because you know the fixed orbit, the concept of fixed orbit, that is not satisfied. There is a probability. You cannot find exact value. You can calculate the probable velocity. You can calculate the probable energy. You can calculate the probable position in a particular region because wave is delocalized. You cannot localize wave at a particular position, but you can localize a wave in a particular region, that 3-dimensional region where this probability of finding an electron is maximum. I didn't tell it is 100%, but it is maximum. There is probability. Where is Irfan sir? Irfan sir is in Irfan sir's home. Where? In which room? Irfan sir's room. The probability that Irfan sir will be in Irfan sir's room, it is very high. Let it be, it's 90 to 99%, but it's not 100%. In some cases, it will Irfan sir will be in any other room. But the probability that Irfan sir will be in its particular room, in its own room, it is very high. Also, the electron in a particular region, the probability, it's very high. It's 90 to 95%. But there is no 100% probability. Probability is 0 to 1. Probability always rises from 0 to 1. Probability can be 0, probability can be 1, maximum 100%. I hope it's clear to you. Okay, nice. Now the thing is, we have to discuss what are the problems related to Schrodinger wave equation, what is the problem related to quantum number. You know that Schrodinger give this equation. It's a great equation. You have to use a higher mathematics. In engineering, we discussed that. We discussed there what is Schrodinger wave equation, how to solve it. It requires higher mathematics. But the thing is, he gave this beautiful equation, but most of the students didn't understand this equation. It's a very complex equation, but as far as your examination is concerned, you have to remember only what is that equation, what is this dou, what is this psi, what is this E, what is this U. You know that this E is nothing but it is the total energy, U is the potential energy, and psi is wave function. It's called orbital wave function. It's called orbital wave function. I hope it's clear to you. It's called orbital wave function. Orbital wave function. Why? Because electron moves. Electron is a wave also. Electron de Broglie also. Electron is a wave. If electron is a wave, then it will move. It will move like different waves are moving. But the waves associated with the electron, those are called de Broglie waves or matter waves. You know that. Wave has some amplitude. Yes, wave has some amplitude. What will be the amplitude? The amplitude will be from mean position. We assume here, you know that what is mean position? Where the system is stable. And what is extreme position? Where the system is unstable, you know that. As system goes from mean position to higher, like simple pendulum, you know that it's a mean position, it's an extreme position. The maximum displacement from mean position, that's called the amplitude. What now? In an atom, there is nucleus and electron revolve around the nucleus in three-dimensional region. What is the maximum possibility it will go? The maximum possibility or the maximum boundary up to which it go, it is this three-dimensional region where probability of finding electron is maximum. That's called the orbital. It means the amplitude of electron wave is nothing. It is the amplitude of the atomic orbital of that electron. In what is that orbital in which electron lies? The amplitude of that orbital will give the amplitude of the electron wave. That's denoted by psi. I hope it's clear to you. I hope it's clear to you. Okay, nice. We'll see. Now what is this? E, total energy, U is potential energy, H is Planck's constant, M is the mass of electron, psi is wave function. You can write this also in this way. H psi is equal to E psi. Sir, what is its short form of Schrondiger wave equation? And this was written by Hamilton. That's why this operator H cap, it is called Hamiltonian operator. See one thing. You cannot cut this psi and this psi. Sir, why? You know that if 2x is equal to, let it be 2xy is equal to 2x, you will cancel x and x on both sides. You will say also that, sir, if H psi equal to E psi, then psi and psi will cancel. But this is wrong. Why this is wrong, sir? Because it has some particular meaning. Like you know that x raised power minus 1, it's equal to 1 by x, 1 upon x. But sine inverse x, it's not equal to 1 upon sine of x. It's not equal 1 upon sine of x. Why? It has some proper meaning. It's an inverse trigonometric function. Also, you know that if H psi is equal to E psi, I am telling you that you cannot cancel psi on both the sides. Why, sir? Because it has some proper meaning that you will study in higher classes. The thing is, you have to remember that you cannot cancel this, and you can write this in another form. You can also write this in another form. That's this: del square psi plus 8 pi square m upon h square E minus u psi equal to 0. Sir, what is this del? Del is called a Laplacian operator. Del is called a Laplacian operator. You can write Schrondiger wave equation also in this form. There is a great contribution of Heisenberg and Schrondiger towards the quantum mechanical model of atom. Very important outcome of when you solve this Schrondiger wave. One thing I forget. Sorry, duster. I hope it's clear to you. One thing I forget, that is, will tell you. You know that there is a three-dimensional region. There is a three-dimensional region around the nucleus. It means electron in a nucleus. Electron will revolve around the nucleus in space. What is space? Space means three-dimensional. To locate a particular point, I am not telling you that electron is at a particular point. I am not telling you that. But the thing is, a body is moving. It's not localized. But to give its position, but that position is changing. What we require? We require some coordinates. Let us suppose the coordinates of that point, it is x, y, z, because it's moving in a space. So space means here three-dimensional. What if electron is moving? Yes, sir, electron is moving. In terms of wave, electron is moving around the nucleus. Sir, it means the position of electron, it is changing. It's not localized. X, y, z will change. The position of electron also changes. One thing is there, the position of electron, that is the amplitude of electron. It will go on changing. Displacement of electron will go on changing. Amplitude will go on changing. It means the amplitude, that's nothing but orbital wave function psi. It will depend upon x, y, z. it will depend upon x comma y comma z. Is that clear to you? Yes. What is the value of x? X can take positive and negative. You know that positive x-axis, y negative x-axis. It is just assumption. What will the values of y? It will be positive or negative. What are the values of z? What are the values of z? It can be positive or negative. It means what will be the value of psi? Sir, psi can take value positive or negative. Psi can take the value of positive as well as negative. That's why in different orbitals, like in case of s orbital, you write this is the s orbital, the shape of s orbital. You write in many books, you see, and you have write with yourself, sir, this is positive, this is negative. Sir, what is this thing? What is this thing? This is nothing but this is the density of electron in one region. This is the density of electron in another region. Which density? Electron density. But here it is positive sign, here it is negative sign. It is nothing but it is a sign of the psi. The amplitude of electron wave, it can take positive or negative sign. I hope it's clear to you. Please write in comment section. I hope it's clear to you. I hope it's clear to you. Please write in comment section. Ayo, yes, whatever. Okay, I will proceed only if you tell me, sir, it's clear. Because Schrondiger wave equation, it seems very difficult topic for many of the students. That's why I take this topic, so that you can understand in a better way. Okay, nice. Now the thing is, sir, psi can take the values of positive as well as negative. Now you that psi, on the basis of psi electron wave function, psi has value, can take value positive or negative, but the probability is always positive. You know, probability is tossing a coin, half probability is that tail comes, half means 50% probability is head comes, 50% probability is tail comes. It means electron is there or there. What is the probability? It can be 0.1, it means 10%, 90%, 30%, 99%. Let it be, it is 100. Let it be, there is no possibility of 100%, but let it be, it's 100%. But the value, these values are positive values. It means probability is always positive. What we take? We take mod of psi square. That's called probability density function. Probability density function, or it's also called orbital density function for an electron. It is probability density function when you square and take mod of this psi, it gives probability density function. It gives that region where the probability of finding an electron is maximum. Sir, how much? Some says 90 to 95% maximum probability. Sir, if there is maximum probability, it means there is some very large probability, but there are some regions where the probability of finding an electron is minimum, or it can be zero. It can be zero. Those regions or those points, these are called nodes. Those are called nodes. I hope it's clear to you. Those are called nodes. Those are called nodes. What is a node? A node is a point, like you study in class 11th, I think, yes, oscillation waves. You study some standing waves. You study some standing waves, and study some transverse standing waves. You study some or you study in, yes, exactly, in organ pipes also. You study when wave is moving, when standing wave is forming, there are some regions, there are some points, medium particles, which vibrate at maximum amplitude. Those are called antinodes. And there are some points, there are some particles of the region, and there are some points where the particles vibrate at zero amplitude or zero displacement. Those regions are called, or those points are called nodes. Here also, the region or the points where the probability of finding an electron it's minimum, those points are called nodes. Here probability is minimum or zero. it can be 0 also, and you can say minimum also. I hope it's clear. Yes. Okay, now there are different types of orbit. You know, there are s orbital, p orbital, d orbital, f orbital. There is a lot of concept regarding the orbitals. Now we'll see one by one. One thing we will see. We'll revise fastly in 5 minutes so that we can cover most of the questions that was asked in JEE or NEET examination. One is s orbital. You know, the s orbit is spherical in shape. This plus, it's not nucleus, it's the sign of wave function. There is some p orbital. P orbital is dumbbell shaped, it's spherical. You write this positive and negative. This, you know, that it is a sign of the wave function. This not, but it is electron density. If you see p orbital along z axis, it will be like that. If you see p orbital along y axis, it will be like that. If you see p orbital along x axis, it will be like that. It is internuclear axis. If you see d orbital, you know that there are 5 d orbital. This is 3 p orbital. There are in p subshell there are 3 p orbitals. In s subshell there are 1 p orbital, because if you see a football in all the directions, what will be the shape? How many orientations will be there? Tell me in a comment section. If you see a football in all directions, how many orientations of football will be there? Tell me in comment section. Tell me fast, comment fast. How many orientations will be there? If you see a football in different directions, like along x-axis, I am telling you 3 directions: x-axis, y-axis, or z-axis. If I will tell you how many orientations are there if you see a football in all the 3 directions, or as a fair, how many? Comment fast. How many orientations will be there? No one is commenting. How many orientations will be there? Comment fast. I'm waiting for your response. How many orientations will be there if you see a football in all the 3 directions? If it is wrong or right, it's no problem. If it's wrong or right, the thing is you write here. Asif Nabi, that's 1. Okay, 1. Any other? Khan Farzana 1. Any other? Where is Hafid? Saifullah, Rizwan, Musab. Where is Hafsa, Zarka, Arbina? Where? How many? Where is Mutair, Fahim? Where is Javed? Tell me fast, how many orientations? Tell me how many orientations. Hafsa, tell me how many orientations if you see a football. Are you scared? No one is commenting. Only 2 comment. Asif Nabi and Farzana. Yes, right. If you see a football in all the direction, how many orientations? It will be 1 orientation. It means when you go from the nucleus, the probability of finding an electron in a region, that particular region, in all the direction, it will be same type. It will be same. That's why in S subshell there are only 1 orbital. But if you see p orbital along z axis, it will be like this. You will see electron density like this. Along y axis, it will be different. Yes. The thing is, the shape will not change. What do you mean by orientation? Here, orientation also depends upon the coordinate axis. Along z axis, there will be different values. Along x axis, there will be different values. If I will tell you this is the same line, I can place this same line like this. If I tell you, sir, these are same lines, but the thing is, what is the angle between these 2 lines? Here, x and y axis, it's 90. What is the angle between y and z axis? It's 19. X and z axis, this is 90. But if I see a sphere in all the directions, the shape will be same. Orientation also will be same. Why? Because the angle, it's totally, this is 360 degree angle. The angle is 360 degree, the complete angle. The thing is, the line is same, but orientation with respect to some different parameters, like angle is there, that will be different angles. This will form an angle with z-axis 90 degree, with x-axis 90 degree, y-axis, these are mutually perpendicular to each other. I am telling you that the orientation, you can place p orbital along z-axis like this, along y-axis like this, along x-axis like this. In the same way, yes, in the same way you can place a d orbital. There are 5 d orbitals, that is dxy, dyz, dxz, dx square, y square, and dz square. There are different orbitals, yes. Okay. Now, how many orbitals are there in d subshell? Sir, there are 3. Those are called axial. These are called between the axes. Why between the axes? dxy orbital means that d orbital, it is double shaped. There are 4 loops like this. It is double shaped. Double shape. Sir, what is dxy? It means this orbit, the loops are between x and y axis. What is dyz? The loops are between y and z axis. What is dxz? The loops are between x and z axis. Sir, what is dz square? Dz square is that orbital which is along x and y axis. Along x and y axis, dz square, it's along z axis. These are along axes, these are between the axes. I hope it's clear to you. Okay. Now, similarly, f subshell, there are how many? 7. G, 9, H, 11, up to so on. Now we know also only s orbital. Sir, you know s orbital, p orbital, d orbital, most probably f orbital. We don't know about g orbital. But since there are only 118 elements, in coming time there will be number of elements. One will take the value of g orbital also. The electron will be placed also in G, H, I, up to so on. Now one thing is there, there are 5 d orbitals. Similarly, there are 7 d orbitals, up to so on. Now I will recapitulate the things that we study in the classes that we take. One thing is, there is a nucleus. For simplification, there is not a particular subshell, there is not a particular shell. For examination purpose, for memory maps, remember thing, there is some shell, and in shell there are some subshells. And in subshells there are some, those are called orbitals. Shell or orbit same. The concept of shell orbit, that was given by Bohr. This came, the subshell orbital, that came when you study quantum numbers, magnetic quantum number, different orientations. One thing is, there are different shells, different orbital. This is n equal to 1, this is n equal to 2, this is n equal to 3, this is n equal to 4, up to so on. According to Bohr, you know energy, velocity, radius of an electron in a particular shell or subshell. You know that in a particular shell. Now one thing is, how many subshells are there? The value of subshell is nothing, the value of n. I will tell you. Sir, how many subshells are in the principal quantum number n equal to 1? Principal quantum number, and it means in shell, first shell. How many subshells will be there? It's the value of n. It's only one subshell, that's S subshell. In n equal to 2 subshell, S subshell and P subshell. In n equal to 3 subshell, S, P and D. In n equal to 4 S, P, D and F. There are 4 subshells. 4 subshells are there. I hope it's clear. Okay. One thing is, how many orbitals are there? Remember that the number of orbitals is nothing but it's the square of that principal quantum number. The shell number is there. Square of that shell number of orbitals will be there. For example, I will tell you, in first shell, how many subshells? Only one subshell. How many orbital? S subshell has only one orbital, then what will be the number of orbitals? It will be only one, that is S orbital. How many orbitals in second subshell? 2 square, that is 4. 1 of S and 3 of P, Px, Py and Pz. Total will be equal to 4. How many in N equal to 3? How many orbitals? 1 of S, 3 of P and 5 of D. Total equal to 9. 3 square is 9. In N equal to 4, 1 for S, 3 for P, and 5 for D, 7 for F. Total equal to 16. So on and so forth. 4 square is 16. I hope it's clear to you. It's a memory map for your examination purpose. Okay. One thing is also there. How many electrons will be there? You discuss it. What is above principle? You know that. What is Pauli's exclusion? What is Hund's rule of maximum multiplicity? You all know that. Well, I will clear you one misconception. One thing I will clear you. How electrons are filled? According to electrons are filled according to above principle, which is based on Pauli's exclusion principle, and also that is based on Hund's rule. One thing is above tell you that electrons are filled in accordance with increasing energy. Electrons are filled in the orbitals with increasing energy. It means you have to place the electron in lower energy, then a lower energy orbital, then higher energy orbital, higher energy, higher and up to so on. How to calculate that? Very easy rule. 1S, 2S, 3S, 4S, 5S. It's a memory map for you. It's 2P. Why 2P? Why didn't I write 1P? Type in comment section, why didn't I write 1P? Tell me fast. I will tell you 10 seconds only. Why didn't I write 1P? Why I write 2P? And why I will write here 3D? And why I will write here 4F? Can you tell me? Comment fast. 5T, 60, 5F, 6F. Tell me, comment fast. Why I write here 2P? Why didn't I write 1P? Tell me fast. See, I write here 2P because the subshell P, it starts from n equal to second. It didn't start from n equal to 1. The D subshell, it starts from n equal to 3. It didn't start from 1 or 2. Similarly for F. That's why I write here 3D, I write here 2P and so on. How to give electronic configuration for memory map? Put arrows like this. What you have to do? Now? We have to do one thing. Guys, just this is a head, this is a tail. Go from head to tail like this. Head to tail. This is head to tail, and head to tail. It means electron will be first placed in 1s orbital, then 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, up to so on. Electron will be placed like this, in this way. First 1s, then 2s, 2p, 3s, 3p, 4s, 3d, up to so on. This is the above principle. Very simple. You have remembered that this in class 11th also, or in JEE examination or NEET examination. If you are, some are preparing for class 11th, some are in NEET examination and so on. Some are preparing for IIT-JEE examination. This is a memory map for you, but one thing is this. The energy of any orbital, it is directly proportional to n plus L rule. It is directly proportional to n plus L rule. Sir, what is n? What is L? We know that there are 4 quantum numbers. One of the important outcome of Schrödinger wave equation, those are called the outcome. Those are called eigenvalues. One of the outcome was that quantum number, those are identification numbers like your identity card, such that in your identity card, what is written? There is a written, what's your name, what's your father's name, mother's name, address, pin code, email, whatever. In the same way, I am not telling you that to locate an electron at a particular point, but to identify electron in which orbital it is, in which region it is. That region you have to locate. Like, where is Irfan sir? You have to tell some person. You have to search online. Yeah, you have to tell any other person where Irfan sir locates. He will tell you, go this way, and you will reach Irfan sir. In the same way, you have to locate electron in a particular region. What is that region? 1s, 2s, 3s, 4s, 2p, 5s, in which orbital? Those numbers, those are magic numbers which will tell you in which orbital electron is. Those numbers are called quantum numbers, and there are 4, one is principal, second azimuthal, third magnetic, fourth is spin quantum number. I hope it's clear to you. Okay, nice. Now, principal quantum number is denoted by N, azimuthal by L, magnetic by M, and spin by S. You know that principal quantum number, it tells you that it was given by Bohr. It tells you that how much is the distance of the electron from the nucleus. It's nothing but shell number. In more detail, you will study class 11th textbook is there. See in detail what is principal quantum number, but we will take some important points that are very important for us in this session. L gives this orbital angular momentum. M, that's a magnetic quantum number. It gives magnetic moment also. It gives magnetic orbital. Also, it gives number of electrons in a particular shell. It gives number of orientation. Important is the number of different orbital. We tell S has 1 orbital only. P has 3. D has 5. Who tell you that? When a spectral line is passed through electric field and magnetic field, it gets splitted according to Stark's effect, according to Zeeman's effect. According to Stark and Zeeman's effect. Those two results that were taken by Goldstein, IPS Goldstein, and he argued that there are different orientations of a particular orbital. Those different orientations, you write 3s subshell has 3 orbitals. It means there are different orientations of S subshell. Those are Px, Py, and Pz. Similarly for D, similarly for F. It gives different order. Similarly, when Earth rotates, what happens? It revolves around the sun also, but the thing is, it revolves around the center mass. You know that in gravitation, and also it spins or rotates about its own axis. In the same way, electron also spins in its own axis, either in clockwise or anti-clockwise. We write that as spin, and we give the value s equal to plus or minus half. Plus for clockwise or anti-clockwise, and minus for clockwise or anti-clockwise. Half. Why half? Probability is electron will revolve clockwise, half probability, anti-clockwise, half probability. Because you know that according to Pauli's exclusion principle tells you that no 2 electrons have the same set of 4 quantum numbers. It means if you have 2 electrons, for example, this first electron, this is second electron. If you have 2 electrons, for this electron the value of n can be same, L can be same, M can be same. For this also this can be same. But the value of S, it is totally different. Why totally different? Because if one electron rotates clockwise or spins clockwise, another should rotate or spins anti-clockwise, because then when the spins of these will be anti-parallel, the opposite poles will face towards each other, and they will permanently clinch with together. Doesn't mean they will make bond, but the system will be stable. Like poles repel, and unlike poles attract. Like you have north pole, south pole, attract, north pole, repel. When because electron is a small current loop, one phase it will be north. Suppose for that also it is north, they will repel. electron, if they repel, system will be unstable. But the thing is, if they are spinning oppositely, it means one is clockwise, another one is anti-clockwise, then what will happen? The north pole of this will face towards the south pole of this. They will attract each other. It means the system will be quite stable. There will be no possibility of instability of the system. That's why Pauli tell you that if there is some orbital, suppose S, P, D, F, whatever, if one electron is clockwise spinning, another is anti-clockwise spinning, if you place third orbital, what will be that? What will be the spin of that, or that electron? The spin of that electron, it will be either clockwise or anti-clockwise. If it's clockwise, it will repel with this electron. If it is anti-clockwise, it will repel with this electron. The system will be unstable. It means maximum the number of electron in a particular, it can be 2. That's why for 2 electron, the value of N can be same in same shell, same value of L, same value of M, but the value of S is totally different. I hope it's clear to you. Is it clear to you? Okay. Similarly, the value of L you can calculate. The value of N, it's from 1, 2 up to so on infinity. The value of L, it's 1, 2 up to so on n minus 1. The value of M is minus L to plus L, and the value of S, it's plus minus half. And you have some memory map. If the value of L for S, P, D and F, for S, L value is 0, 1, 2, 3. M value, the value of M, it's minus L to plus L. It will be plus minus 0, that is 0. It will be plus minus 1, 0, minus 1 to plus 1, minus 1, 0, plus 1. It is 3, the value 1, 3, plus minus 2, plus minus 1, 0, will be 5. Similarly for this, it is 7. Those are the number of orientation. Those are called number of orbitals. Okay? Magnetic quantum number, you gives the number of orientation. This is the number of orbitals. Similar for spin, you can calculate also. I hope it's clear to you. And also there is one thing is there. Hund's rule of maximum multiplicity. What Hund's will tell you that, for example, if you have, for example, if you have d orbital, suppose, or if you have p orbital, there are 3 orbitals for p subshell, px, py, and pz. How you will place the electrons? Sir, you will place the electrons first. How? If there are 5 electrons, let it be there are 4 electrons. Let it be there are 4 electrons. What you will, 1 electron, 1 electron, 1 electron. One possibility is this. You can also write this as 4th electron will be like this. You can write also this as this and this. 4 electrons, 4 electrons. But this one is wrong, this one is right. Who's tell you that orbitals of a particular subset, these are degenerate. These are degenerate. What do you mean by degenerate? They are same, they are identical. It means, tell me, it means if this has some energy, this will have same energy, this will have same energy, this is similar to that, but in orientation, you know that along different axes they are different. Along different axes their behavior is different, but they are identical in energy. This orbital will tell you that if you are filling the electron, in this orbital singly first, then I am similar to that of these orbital, then I should be firstly filled singly. That I should be first filled. It means orbitals are filled singly first, then pairing of electron takes place. Then you will pair the electrons. First, what you have to remember, you will fill the orbitals first singly, then pairing takes place because orbitals are degenerate. That's Hund's rule of maximum multiplicity. Okay, I hope it's clear to you, and you know that half filled and fully filled, these are highest stable. Why these are highest stable? Because the thing is, there are more exchanges possible. If there are more exchanges possible, more loss of energy. Less system with less energy, more loss energy means system has least energy. System with least energy according to thermodynamics, the system will be stable. This completes your total atomic structure. One thing is, energy of any orbital, it's directly proportional n plus L. It's also called n plus L rule. N is the value of N is the value of principal quantum number, L is the value of azimuthal quantum number. How to calculate energy, how to calculate all those things, how to calculate different things, we'll see in questions. I hope we should start the questions. I hope it's clear to you. I hope it's clear to you. Please tell me, shall we start the questions? Do anyone have some queries? Do anyone have some questions? Tell me in comment section below. Tell me in comment section. Shall we start? Shall we start the questions? No one is telling. Sorry, no one is telling yes or no. Tell all of you. Shall we start the questions? We'll take some questions. Only 5. It will be 10 to 15 minutes only. 10 to 15 minutes. Okay, sir. Okay. Are you ready? Okay. Hafsa ready, Zarka ready. Farzana ready. Where is Hafid? Saifullah, Rizwan, Sharik. Where is Mutair? Are you ready or not? Are you ready? Shall we take the questions? Shall we take questions? Where is Javed, Fahim? Where is Asif? Shall we take questions? Oh yes. Okay. Okay, we'll start. The first question for you is this. Tell me. We'll tell you one thing. Well, is question visible to you? Yes, this is the question for you. Tell me, is it visible? Is it visible? Tell me. Yes. Yes, it is visible. Okay. Hi, Tushar Chauhan. Hi. Tell me the answer of this question. The number of orbitals associated with quantum number n equal to 5 ms is Hafsa 25. Tell fast. Tell me fast. सब लोग बताओ. सर अभी तक अंग्रेजी कर रहे थे, अब क्या उर्दू हिंदी सब करोगे सर? सब चलेगा इधर. जब क्वेश्चंस की बौछार आती है हमारे पास, तो हम हर कोई लैंग्वेज यूज करते हैं, चाहे वो इंग्लिश हो, चाहे कोई भी लैंग्वेज आपके पास हो. ठीक है. व्हाट इज द आंसर फॉर दिस क्वेश्चन? खान फरजाना फर्स्ट, हफ्सा 25, जरका 25. All of you tell me what is the answer for this question. How many orbitals are associated with quantum number n equal to 5? It means in shell n equal to 5, in fifth shell, how many orbitals are present? For that, the value of ms means magnetic quantum number is plus half, means all those electrons are moving anti-clockwise. It means there is upspin. It means there is upspin. Half it 25. Yes. Yes, the answer is 25. How? Tell me. Yes. Yes. What is the answer? Answer is 25. How? You know that the number of orbitals, it's nothing but it's equal to n square. The value of n is 5 square, that's 25. This question was asked in JEE 2020. It's in 7th Jan morning session. Very easy question. Yes. Okay. Next question for you. I hope everyone understands. Yes, Arbina, right answer. 25 is right answer. Everyone understands that number of orbits is nothing but it's equal to n square. The value of principal quantum number, you have to square that. Okay. N square, yes. The next question for you will, yes. This is the reason for that. And no, this, what is the value of this? Can you tell me what's the value of this? What's the value of this? Now am I audible to you? Okay. Tell me the answer for this question. Yes, okay. Tell me the answer for this question. Okay. Amongst the following, which is not a postulate of Dalton's atomic theory? Which one of the following is not the postulate of Dalton's atomic theory? Tell me the answer. Which option is correct? It's a very easy question. It's a type of makhan question. Tell me what's the answer for this question. Amongst the following, which is not the postulate of Dalton's atomic theory? Matter is formed of indivisible atoms. When gases combine or reproduced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at STP. During chemical reaction, atoms remain conserved and only pass through rearrangement. Some atoms have same property, including atomic mass. Zarka option number 2. Hafsa option number 2. Anyone else? Tell fast. What is the answer? Khan Farzana 2. Hacker 2. Who is hacker? Is it Javed? Hacker? Okay. Tell me, Hafid, where is Hafid? Where is your answer? Where is Saifullah, Rizwan? Where is Mutair, Fahim? Where is Javed? Where is Sharik? Tell me the answer. Yes. No, sir. Yes, the answer number 2 is correct. Why? Why? I will tell you. Why answer number 2 is correct. We know that what's Dalton's atomic theory? What Dalton's atomic theory tells you? What Dalton's atomic theory tells you? Dalton's atomic theory tells you matter is made up of small indivisible particles. Those are called atoms. Those are indestructible. You know that. Dalton also tells you that atoms of same type of element are similar in every respect, mass, whatever. Atoms of different elements are different in every respect, and they combine in a simple whole number ratio by mass. It means Dalton's atomic theory explains all the laws of chemical combination by mass, not by volumes. And Dalton also tells that it's an whole atom which take part in a chemical reaction, and it's an atom which take part in a chemical reaction. Also, atoms combine. There is a rearrangement. There is a rearrangement of atoms. Yes, it means option number 2. That is, I hope option number 2. When gases combine or produced in a chemical reaction, they do so in a simple whole number ratio. That is Gay-Lussac's law. That's a law of chemical combination by gaseous volumes. That's a law of chemical combination by gaseous volumes. Law of chemical combination by gaseous volume. But Dalton tell you that we can explain all the laws by mass. I hope it's clear to you. Okay, the answer for this is option number 2. Oh, these type of question which I will share this PDF with you in description box, and all the PDFs of the previous sessions in description box. Yes, Arbina, right answer. Tell me the answer of this question, because the questions we are skipping here, we discussed these type of questions in previous sessions. That's why I am skipping you, but these questions will be as homework for you. I will share you this PDF in description, and you can download that PDF. Tell me the answer for this. Ask in JEE Mains 2019 8 April morning session. Tell me the answer for this. Tell me the answer for this. Tell me answer. Hafsa 4. We'll see. Okay. Khan Farzana 4. Others also comment. Asif Nabi 3. We'll see what will be the answer. Okay, what's the answer? Yes, what is the value of n equal to 4, L equal to 2, and ml equal to -2? You can write ml or ms, that same magnetic quantum number. In the first option, we'll see. In the first option, I will. Okay, where is the PDF? Zarka Rafiq 4. Most of the students are giving the answer 4. It means the answer number 4 is correct. It means the answer number 4 will be correct. We'll see which answer is correct. Okay, we'll see. Okay, where is the PDF for me so that I can see the question? Yes, this is the PDF for me. And what's the first option? Sir, you know that energy of any orbital, the energy of electron in any orbital, it's given by n plus L rule. It is the energy of electron in any orbital. It is directly proportional n plus L rule. Remember that more the value of n plus L, more will be energy. If n plus L is same, remember that if n plus L is same, if the value of n plus L is same, that energy, it is directly proportional to the value of n. The one which has the highest value of n will have the highest energy. Now what will be the answer for that? For first, n equal to 4, L equal to 2, m equal to -2. We don't have to bother about value of m and ms. Ms is the value of spin quantum number, ml is the value of magnetic quantum number. we are bothering about n equal to 4, L equal to 2. That's the first option. Second is n equal to 3, L equal to, that is 1. Third option, n equal to 4, L equal to 1. And fourth option, n equal to 3, L equal to 1. What is the value of n plus L? 4 plus 2 is 6. 4, 5, 4. Yes, it means the energy of first, it is greater than energy of third, and it is greater. What is there? The n plus L value same. The value of n plus L is same. Energy is directly proportional. The one, it's n equal to 3. Third, what was the fourth option? 3 and L equal to 1. N equal to 3. L equal to, is this L equal to, n equal to 4, L equal to, n equal to 4, L equal to, n equal to 3, L equal to 2. In this option, it's in option in second option, it's L equal to 2. Yes, L equal to 2. It's 5. In 5, yes. Now for this, what will be the answer? The first has the highest energy. Then in these two, what will be the answer? The value of n is greater in this. What will be the, because the n plus L value is same, the value of n is greater in this case. It means third, then it will be second, then it will be first. What will be the option? Fourth has less. Then fourth, sorry, it's fourth, then fourth. It means fourth has less energy, then second, then third, then first. Option number third is correct. Option number third is correct. Yes, Sharik Baba. Yes, Asif, right answer. Yes, Sharik, right answer. Yes, right answer. What's happening? You have to check n plus L rule. Yes, you have to check, sir, n plus L rule. What n plus L rule tells you? That n plus L rule tell you that more the value of n plus L, more will be the energy. What is the value of n plus L? In this case 6, in this case 5, in this case 5, in this case 4. It means energy of first, it is highest. What is the energy of second and third? What will be the order? The order will be, if n plus L is same, the one with higher value of n will have the highest energy. What is the higher value of n in these two cases? That is third. It's third. It means one has greater energy than third, and third has greater energy than second, and second has greater energy than fourth. This is the order. I hope it's clear to you. Yes, I hope it's clear to you. Okay. Okay, next question we will see. Next question we will see. Tell me the answer for this. Tell me the answer for this. Tell me the answer for this. What's the answer for this question? Tell me the answer for this question. Fast, comment fast. Okay, Saifullah. Where were you, Saifullah? Are you skipping the class? Are you skipping the class? Okay, tell me the answer for this question. Tell me the answer for, it's a very easy question. Rizwan Hakak 2. Okay, Rizwan Hakak 2. Anyone else? Anyone else? To the group number of valence electron, valency of an element with atomic number 15 respectively are. Khan Farzana second, Asif second, Khan Farzana second. Okay, okay, we'll see. The question was for this. What will be the, it's 15 5 3 16 5 3. For 16 and 15 there are two elements with atomic number 15 and 16. We'll see. With atomic number 15, if the atomic number is 15, what will be the electronic configuration? 1s2, 2s2, 2p, 2p6, 3s2, because 6 2 2 8 10 12, 3p3, 3p3 for atomic number 15. What is the atomic number? Z equal to 15. How many valence electron? 3 plus 2 is 5. It is last shell. And the value of n is 3. The value of n is 3. If the value of n is 3, what it means? These two subshells will lie in same shell. The number of valence electron is the number more in the outermost shell. What are the number of electrons? Those are called valence electron. 3 plus 2 is 5 electrons. And what is the valency? Number of unpaired electron. You know that. What is valency? Number of unpaired electron. In 3s, 2 electrons. In 3p, how many electrons? 3 orbitals. It means 3 electrons. 1 2 and 3. How many unpaired? 3 are unpaired. It means valency is 3. It means option number 2 is correct. Yes, Farzana, option number 2 is correct. The option number 2 is correct. Option number 2 is correct. Yes, option number 2 is correct. Okay. Yes. So we'll see. Proceed. Tell me the answer for this. Tell me the answer for this. What will be the answer for this? Sorry. The answer is given. I will skip this question. Okay, there are this type of questions we done in earlier session. These type of questions we done in earlier session. These type of questions we done in earlier session. Also, it's based on photoelectric effect. We done this. This also we do. This also. Oh, tell me. Okay. Tell me the answer for this. Tell me the answer for this. Tell me the answer for this one. Hapsa one. This one. Yes. I am skipping those questions which we have done in earlier sessions. Darka one, again one, again one, again one, again one. Yes. Now I am changing the question. Now I am changing the question. How many nodes are there? I will write the question, same question, but now I will write in a different way. Same question, I will write in a different way. The number of radial nodes. In 3s and 3p. It was 3s and 3p. Now I will tell you what are the number of radial nodes in 4s and 3d orbitals. Tell me what is the answer for this. Tell me answer. 4s and 3d. There is a 4s orbital and 3d. Number of radial nodes. Tell me, and I will give you some options. Option A, B, C, and D. Radial nodes in 4s and 3d orbital. Tell me the value. I will give you some options. 0, 1, 2, 1. I will tell you. It is 4, 3. One is 0, 2. One is 1, 2. What is the option? Hapsa 3, 0. 3, 0. No option is matching. 3, 0. No option. Tell me the option. Hapsa 3, 1. 3, 1. Wrong answer. I'm giving these type of options. Option A, option B, option C, option D. What's the right answer? Tell me fast. Tell me fast what is the right answer. What is the right answer? Tell me fast. Tell me fast. Okay. Tell me fast. Okay, no one is commenting. One thing is number of radial nodes. There are two types of nodes. Number of radial nodes. Number of radial nodes, it's equal to number of radial nodes, it's equal to L. The value of L. The value of L, it's equal to number of radial nodes. And we know that for S, P, D and F, the value of L is 0, 1, 2 and 3. What is the number of radial nodes in 4S? We don't have to bother about what is the value of N. We have to bother about what is the value of L. The value of L for 4S or S, it is equal to 0. It means number of radial nodes, it's 0. It means option number B and option number C are incorrect. Now the race is between option number A and option number B. The value of L for d orbital, it is 2. It is 2. It means option number C is right answer. 3, 0 आ रहा है मेरा B. Where is 3, 0? No 3, it's 0, 2. I hope it's clear. I hope it's clear. Okay. Now one thing is there are another number of nodes. Those are called axial nodes. One is radial node. I forget the name. What is the name? Can you tell me? N minus L minus 1. Yes. What are N minus L minus 1? Those are called? I forget the name. Tell me the name for that. Oh, sorry. This is the formula for angular nodes. Sorry. If I am asking you for angular node, this is the right answer. For radial nodes, it's wrong answer. Radial nodes, the radial nodes, it's equal to N minus L minus 1. N minus L minus 1. I hope Zarka, Hafsa और मेरा ठीक है. Yes, we'll see. Yes. Angular nodes, the value, the number of angular nodes, it's equal to L. The number of radial nodes, it's equal to N minus L minus 1. What is the value of N? It is 4. What is the value of L for S? It's equal to 0 minus 1. 4 minus 1 is equal to 3. For that, number of angular nodes, it's equal to 3. And for that 3D, the value of N is 3. The value of L is 2 minus 1. It's equal to 0. It's equal to 0. It means the option. What is the option? I will tell you. I will write the answer. The answer is 4 minus 0 minus 1. 4, that's 3. Comma, it is 3 minus the value of t, it is 2 minus 1, that's equal to 0. 3, 0 is the right answer. 3, 0 is the right answer. No one. Yes, Zarka gave the right answer, that is 3, 0. Zarka gave the right answer, 3, 0. And I hope also Hafsa. Yes, the right answer, Hafsa gave the right answer first. Then Zarka. Yeah. Yes, Hafsa. Yes, Hafsa. Hafsa wins. Yes. Yes. Okay. Yes, Hafsa wins. Okay, next. I will see. What is the next? Okay, there's some problem with that. What are different questions? Okay, we'll see where are. Is there any other question that we skipped? Yes, tell me the answer for this. 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 Hafsa Ijaz 1. Hafsa Ijaz 1. Tell me the answer for this. 1 1 1. It can never be 0 for 2s orbital. Anyone else? Tell me the answer for this. What is the answer? This is the last question. This is the last question we are discussing. This is the last question for atomic structure we are discussing. Tell me what is the answer for this question. Tell me the answer for this question. Hafsa 2, shayad Hafid 2. Hafid 2. Hafsa can be 0 for 3p. Can be 0 for 3p. We'll see. See. The question for me, it's like this. Which of the following are the correct statement about the probability density function? Probability density function is mod of psi square. Mod of psi square. Except at infinite distance, it can never be 0 for 3s orbital. It can be 0 for, yes. for that one thing is we have to we know that probability density function is mod of psi square. It can be 0 or it can never be 0. It depends upon the number of nodes, the value of psi with respect to r. Where if it will touch this axis, then it will have some probability equal to 0 there. Some probability here equal to 0. This probability is in one section, in one region, it's in another region. Here the probability is 0. It crosses this axis. It means this is node, this is node. For that we have to calculate node. And which type of node? It depends upon r, and we have to calculate radial nodes. We have to calculate here radial nodes. Now what is the formula for radial nodes? N minus L minus 1. First of all, what is 1s orbital? For 1s orbital, what is the value? 1 minus 0 minus 1, that is 0. That is 0. And for 2s orbital, it will be 2 minus 0 minus 1, that will be 1. For 2p orbital, it will be 2 minus 1 minus 1, that will be 0. And for 3p orbital, what will be the value? It will be equal to 3 minus 2 minus 1. It's 3p orbital. Yes, 3 minus 2 minus 1. It's 3p orbital. It will be 3. It's 1 1. That will be 3. It will be 1. Also for mod of psi square, if we plot the graph for these 1s, 2s, 2p and 3s, is it this? Yes. For that, mod of psi square is also different from 0. For that, it's equal to 0, and this is different from 0, and this is 0. Now tell me which option is correct? Which option is correct? It's option number. It can never be 0 for 2s orbital. It can never be 2s orbital. It can be 0 for 2s orbital. We calculated that. It can be 0 for 1s orbital. For 1s or mod of psi square cannot be equal to 0. It's always positive. It cannot be 0. It's non-zero. Non-zero means it cannot take the value of 0. It can be negative for 2p orbital. No. It's always positive, but it cannot take the negative value, because mod is mod of psi square. It has a probability density. Probability is always positive. It cannot take negative. It can be 0 for 3p orbital. Yes. It can be 0 for 3p orbital. It means option number B is correct, or option number 2 is correct. Yes. Yes, Hafsa. Yes. Hafid. Yes. Yes, Saifullah. Okay. I hope this session was very nice for you and for me also. I completed every topic regarding the quantum mechanical model, and we discussed what is the de Broglie, what is Heisenberg, what is Bohr, different kinds of different topics that were in atomic structure or dual nature or electromagnetic waves, or that were asked in radioactivity. We discussed in previous sections, and this was the last section that we discussed regarding Schrondiger, regarding electronic configuration, regarding number of nodes, quantum numbers. I hope it's very easy for you now. I hope I do very I hope these things, one important thing, that is Schrondiger, one is Heisenberg, another one is that is the this thing quantum numbers. These are very important, and de Broglie and Bohr. These are very important topics as far as your entrance examination is concerned. Important, why important? Because most of the questions are asked in these. In what is asked in Schrödinger? This wave function regarding psi, I hope it's clear to you. Okay, nice. Okay, thank you. Okay, thank you. Nice. Please share, like, subscribe, share with your friends also.